Welcome, my dear learners, to today's episode on this very channel. In today's lesson, we shall be looking at exponential equation leading to a quadratic equation. That is what we are going to do in this very lesson. But before we start with the actual calculation, let's kindly remind ourselves on two of the laws of indices that we are going to make use of it frequently in this aspect. So we said that when you have two numbers multiplying, they have the same base. What we do is that we pick one of the base and then we add their exponents. That is what the multiplication law. When you have two or more numbers multiplying, they have the same base. We pick one of the base, we add their exponents. So when you have, let's say, 2 raised to the power x plus 3, applying the multiplication law, we can write this in the form of this. So we are going to have 2 raised to the power x multiplying 2 raised to the power 3. Because we said that when you have two or more numbers multiplying, they have the same base. We pick one of the base, we add their exponents. So this is the same as that, applying the multiplication law. Similarly, when you have, let's say, 5 raised to the power x plus 2, we can write it as 5 raised to the power x multiplying 5 raised to the power 2, applying the multiplication law, which says that when you have two numbers multiplying, they have the same base. We pick one of the base, which is this one, we add their exponents. So this is equal to that. Let's look at the other law. Now we said that when you have, let's say, a raised to the power m or raised to the power n, applying the power law of indices, we can write this as a raised to the power m multiplying n, which is the same as what? Mn. So in applying it, when you have, let's say, 2 raised to the power 3x, applying the power law, we can write this as 2 raised to the power x or raised to the power 3. That is what the power law. And this is the same as that, and this is the same as that, applying the power law. Similarly, when you have, let's say, 7 raised to the power 2x, we can write this as 7x raised to the power x or raised to the power 2, applying the power law. So these are the two laws that we are going to make use of it more often in this regard. Now let's solve our examples. So we are to solve for x in this exponential equation. So as we said earlier on, when you have 3 raised to the power 2x, applying the power law, we can write this as what? 3 raised to the power x or raised to the power 2, applying the power law. I believe you agree with me. Good. So in place of this, we are going to write this. So we have 3 raised to the power x or raised to the power 2 minus 4, 3 raised to the power x plus 3, and that gives us 0. Now you realize that we have 3 raised to the power x, 3 raised to the power x. Let's represent this 3 raised to the power x by any variable at all, any variable letters of the alphabet from A up to letter Z. We can choose any variable at all. So let's choose the variable y. So we are going to let y equal to 3 raised to the power x. So it means that wherever I see 3 raised to the power x, we are going to replace it with what? Y. So we have y, and then we have 2. So y raised to the power 2 minus 4, and then we have y plus 3, and that gives us 0. So realize that we are having what? A quadratic equation. And in solving quadratic equation, we have so many methods that you can use. You can use the computing of squares, you can use the quadratic formula, you can use the factorization, and you can also use the calculator. So let's use the factorization approach. So with the factorization, we are going to find two numbers that when you multiply, we are going to get 3. that when we sum these two numbers, it is going to give us what? Minus 4. And these numbers are minus 1 and then minus 3, because minus 1 times minus 3 give us positive 3. When we sum them, we are getting minus 4. So we are going to substitute these numbers in place of what? Minus 4y. So we shall have y raised to the power 2 minus what? Y minus 3y plus 3, and that gives us 0. Now let's factorize. We can factorize y out. We are left with y minus 1. And then here too, we can also factorize 3 out. We are left with y minus 3. And that gives us 0. This one is 1. Since the two brackets are the same, we can pick one and then we pick those outside the bracket. We put them also in the brackets. So we have y minus 3. And then we have y minus 1. That gives us 0. Let's continue from this side. So for me, you can say that our y minus 3 is equal to 0, or y minus 1 is equal to 0. Now we are looking for the value for y. So from here, our y is equal to 3, or our y is equal to 1. Good. Now we said that we are letting y to represent 3 raised to the power x, because in the question you don't have any y inside, so we have to deal with that. So we said that y is equal to 3 raised to the power x. So we have is equal to 3 raised to the power x. So our y is 3 is equal to 3 raised to the power x. Now 3 is the same as 3 raised to the power 1, because 3 raised to the power 1 will give you 3. So we can write this as 3 raised to the power 1. Now since the bases are the same, what we have to do is just equate their exponents. So we have our x to be equal to 1. So we have two solutions for y. So we have y is equal to 3, or y is equal to 1. So we have to solve for the other one. Y is equal to 3x. So we have 1 is equal to 3 raised to the power x. Now applying this property, we said that when you have any non-zero number raised to the power 0, it is equal to 1. Any non-zero number. So it means that we can write 3 raised to the power 0, and this is going to give us 1. So in place of 1, we are going to write 3 raised to the power 0. So we have 3 raised to the power 0. That gives us 3 raised to the power x, because this will give us 1. Now once the bases are the same, we just have to equate their exponents. We have x is equal to 1, or x is equal to 0. So the value for x that satisfy these equations are x is equal to 1 or x is equal to 0. You can cross check your answer to see we are saying that our x is equal to 0. So we have 3 raised to the power. This will give us 0 minus 4. This also give us 3 raised to the power 0 plus 3. Let's check it to see if it is going to give us 0. This will give us 1. This is also giving us 4. This will give us 1, so 4 plus 3. So when you sum this, it is giving us 0. And this means that 0 satisfies this equation. You can cross-check the one and see, and it is going to give you what? 0. Let's look at our next example. We are to solve for the value of x in this exponential equation. So as I said earlier on, when you have a raised to the power m or raised to the power n, applying the power law, we can write it as a raised to the power n. Similar, when you have this, you can write it as that. So 2 raised to the power 2x, applying the power law, we can write it as 2 raised to the power x or raised to the power 2. You agree with me? So we have 2 raised to the power x or raised to the power 2 minus 5, 2 raised to the power x plus 4, and that gives us 0. Now since we have 2 raised to the power x, 2 raised to the power x, let's represent it with any variable at all that we like. So let's choose y. So we are going to let y equal to what? 2 raised to the power x. So in place of 2 raised to the power x, we are going to substitute what? Y. So we have y raised to the power 2 minus 5y plus 4. That gives us 0. So we have a quadratic equation, and you can use any of the methods that I mentioned to solve for this. You can use your calculator to find the value for y. You can also use the factorization. So let's use that. So we have to look for two numbers. That when we multiply, we are going to get 4. That when we sum them, will give us minus 5. And these numbers are minus 1, minus 4. This will give us positive 4. And when we sum them, we have minus 5. So we are going to substitute these numbers in place of minus 5y. So we have y squared minus y minus 4y plus 4, and this is equal to 0. So factorizing y out, we have y minus 1, then we have 4 out, we have y minus 1, that gives us 0. Since the two brackets, the terms within the two brackets are the same, we can pick one of the brackets and then we pick those outside the bracket, we put them in a bracket as well. So we have our y is equal to 4 from here, or our y is equal to 1 from here. Now, since the equation we don't have y within, we introduce it by letting y is equal to 2 raised to the power x. So we have to deal with the y. So we said that our y is equal to 2 raised to the power x. Our y here is 4 is equal to 2 raised to the power x. Now we want the basis on each side of the equal sign to be the same. So we can write 4 as what? 2 raised to the power 2, and this is equal to 2 raised to the power x. Since the bases are the same, we just have to equate their exponent. Therefore, our x is equal to 2. Now we had two values for y. So let's deal with the other one as well. So we said that our y is equal to what? 2 raised to the power x. Our y is equal to 1. So 1 is equal to 2 raised to the power x. Now we can write 1 as 2 raised to the power 0. Because 2 raised to the power 0 will give us 1. And then we have 2 raised to the power x. Since the bases are the same, we just have to equate their exponent. So the value for x that satisfies these equations are 2 or 0. Let's look at our other set of questions. So we have our next set of questions. We have to solve for the value for x in this exponential equation. So looking at this, we have 2 raised to the power 2x plus 1. Applying the multiplication law, we can write this as 2 raised to the power 2x plus 1. We can write it as 2 raised to the power 2x multiplying 2 raised to the power 1. Because applying the multiplication law, we said that when two numbers are multiplying, they have the same base. We pick one of the base, we add their exponent. So this is equal to that. So in place of this, we can write this. So we are going to have 2 raised to the power 2x multiplying, let's make it like this. 2 raised to the power 1, and then we have 9, 2 raised to the power x plus 4, and that gives us what? 0. Now with this 2 raised to the power 2x, applying the power law, which is that when you have a raised to the power mn, you can write it as a raised to the power m or multiplying n. So in place of this, you can write 2 raised to the power x or raised to the power 2. So we have 2 raised to the power x or raised to the power 2 multiplying 2 raised to the power 1, which is the same as 2. And then we have 9. Yeah. So we have 2 raised to the power x, 2 raised to the power x. Let's represent it with any variable at all. So let what? Y equal to 2 raised to the power x. Wherever we see 2 raised to the power x, we have to represent it with what? Y. So we have 2y raised to the power 2, and then we have minus 9y plus 4. That gives us 0. So we now have a quadratic equation, and we can solve it using any of the four methods that I said earlier on. Now, using the factorization method, we are going to multiply 2 by 4. That gives us 8. And we have to look for two numbers that when we multiply, we are going to get 8. And then when we sum, it should give us what? Minus 9. So we have minus 1 and then minus 8. Because minus 1 times minus 8 will give us positive 8. When we sum it, we are getting what? Minus 9. So we are going to substitute minus 1 minus 8 in place of minus 9. So we have 2y squared minus y minus 8y plus 4. That gives us what? 0. So let's factorize it out. We have y, so we can factorize y out. We are left with what? 2y minus what? 1. Now we have minus 4. We are left with 2y minus 1. That gives us 0. Since those terms within the brackets are equal, we can pick one of the brackets, and then we pick those outside the bracket, we put them also in the bracket, and this is equal to 0. So we have our 2y minus 1 is equal to 0, or y minus 4 is equal to 0. So we have our 2y minus 1 is equal to 0. You can see that our y is equal to 1 over 2. And from here, we say that our y minus 4 is equal to 0. We can see that our y is equal to 4. Now within the question, we don't have y. We introduce it. So we have to deal with it by coming back to this part where we said y is equal to 2 raised to the power x. So we have our y is equal to 2 raised to the power x. And we have our y to be what? 1 over 2. And then 2 raised to the power x. Now we want the basis on each side of the equal sign to be the same. And applying this negative index property, which says that when you have a raised to the power negative 1, you can write it as 1 over a. Or when you have 1 over a, you can write it as what? A raised to the power negative 1. So we are going to apply this property to write this as that. So we shall have 2 raised to the power negative 1 is equal to 2 raised to the power x. Now once the bases are the same, we equate their exponents. So we have our x is equal to negative 1. Now let's look at this one. We also said that y is equal to what? 2 raised to the power x from here. And then our y is equal to 4. So we have 4 is equal to 2 raised to the power x. Now let's write 4 in an index form to a base of what? 2. So we can have 2 raised to the power 2 is equal to 2 raised to the power x. And once the bases are the same, we equate their exponents. So therefore, the value for a that satisfies these equations are minus 1 and positive 2. Very, very easy. Let's look at our last example and then bye-bye. Applying the power law, we can write the whole of this as 3 raised to the power x all raised to the power 2. And then we have minus 30. Applying the multiplication law, we can write this as 3 raised to the power x multiplying 3 raised to the power minus 2. Because when you apply the multiplication law on this, we are going to have 3 raised to the power x minus 2, and we are back to the same thing. So we are going to write this as 3 raised to the power x multiplying 3 raised to the power negative 2 plus 1 is equal to 0. So we have 3 raised to the power x all squared minus 30, and then we have 3 raised to the power x. Now, when you have a raised to the power negative 1, we can write it as what? 1 over a. So we are going to apply this negative index property to write this as that. So when you have 3 raised to the power negative 2, you can write it as 1 over 3 raised to the power 2, applying this property. Let's do some small algebra here. We have 3 raised to the power x all raised to the power 2 minus 30, 3 raised to the power x all over what? 9 plus 1. That gives us what? 0. So from here you can see that 3 can cancel 9 and then 3 can cancel 30. We have 10. So we are having 3 raised to the power x all raised to the power 2 minus 10 all over 3. Then we have 3 raised to the power x plus 1 is equal to 0. Now we don't want to have any fractions again, so let's multiply through by the denominator of this very fraction. So we shall have 3 multiplying 3 raised to the power x all raised to the power 2, and then we have 10, 3 raised to the power x plus 3, and this gives us what? 0. Now let's introduce a new variable. So we are letting y is equal to what? 3 raised to the power x. Meaning that wherever we see 3 raised to the power x, we have to substitute what? Y. So we have what? A quadratic equation. So let's continue from this side. So applying the factorization method, we are going to have this will give us 9. Then after that, we look for two numbers that when we multiply, we are going to get 9. That when we sum them, we are getting minus 10. And these numbers are minus 1 and then minus what? 9. This will give us positive 9 and this is giving us what? Minus 10. So we have 3 raised to the power y squared minus what? Y minus 9y plus 3, and this is equal to 0. We just substituted these numbers in place of what? 10 here. So let's do some factorization here. We have y. We can factorize y out. We are left with what? 3y. We are left with what? 1. We have minus 3, and then we have 3y plus what? Minus 1 is equal to 0. Since those within the two brackets are the same, we can pick one of the brackets, 3y minus 1, and then we pick those outside the bracket. We put them also in the bracket. So from here, you can say that our 3y minus 1 is equal to 0, or our y minus 3 is equal to 0. So we have our y is equal to 1 over 3, or our y is equal to positive 3. So we said earlier in the beginning that we are letting y is equal to 3 raised to the power x. So we said that y is equal to 3 raised to the power x. And we had our y to be 1 over 3, and then we have 3 raised to the power x. Now applying the negative index property, we can write this as 3 raised to the power negative 1 is equal to 3 raised to the power x. And once the bases are the same, we have our x is equal to what? Negative 1. Now we said that our y is also equal to positive 3. So we have to deal with that one also. And then we have 3 is equal to 3 raised to the power 3. Since the bases are the same, we just have to equate their exponent. So the value for x that satisfies this exponential equation x is equal to minus 1, and then x is equal to positive 1. So this is your 2 answer question. Bye bye.